Next question. Pulleys. Oh, look at that. 15 marks. These are just easy questions, man. Oh, that's the last question. Just 7 questions? Well, I think we usually get 7 questions right. Okay, 7. It says one end of a light and extensible string is attached to a particle A of mass 2m. There we go, 2mg. And there we have 3mg. There's just 0.5 meters, and the other one, okay, blah 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 blah. Blah 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 blah. Just both parties ahead of distance, blah blah blah. Okay, the system is released from rest and B moves downwards. Of course, B is gonna move downwards, well, because B is heavier. That's just common sense. So B accelerates downwards with some acceleration A, and A moves upwards with some acceleration A as well, because they are connected. If the two particles are connected, they're going to move together, meaning they're going to have the same acceleration, the same velocities at each moment, at every moment in time, and whatnot. They're going to be traveling the same distances in every time, you know what I mean, in every change in time. So yeah, that's what that is. So you have acceleration. And also, why can we assume that both of them have the same acceleration? It's actually based on the assumption that the string is inextensible, because if the string was not inextensible, what would happen? Well, just imagine B is trying to go down, and it is falling down, but the string is stretchable. Wait, what the frick did I just say? Okay, no, I said inextensible, but now if the string was extensible, if you could stretch it, okay? B is trying to go down, it's going down, and then you just see the string stretch, like somewhere here. So if it's stretched, that would mean that A is actually not moving with B, essentially. I hope you could visualize that. I'm not sure if I can explain it better. I'm sorry about that. But yeah, that's what that is. And usually they ask you how we have used the assumption that the string is inextensible, right? You would then say that the acceleration for A and B is the same, or are the same? Never mind. Okay. Oh, and another question is, they could ask is, yeah, they wouldn't ask about the assumption light string. The string just has no mass. That's just better for us. I don't know. I guess you could look at chapter 1. There's a giant table. Everything's right there, okay? And I'd recommend, just before going to the exam, you go through that. That's really gonna help you a ton, I promise. Because just before the exam, like when you're, let's say, on a journey to the exam hall, like you're not gonna solve more questions, right? So it's best if you just have a look at the conceptual stuff that they could just ask, you know, and then just so that later you don't regret. That's really what it is. Okay, we just have to find out the tension. I yap a lot, man. We just have to find out the tension here. Let's go. That's tension. Oh, and again, same analogy. That is, this is not exactly the tension that is acting on A and B. It's actually the reaction force, because the string is actually connected to A, let's say. Connected means there's going to be contact force, and there's going to be reaction, let's say, reaction force. And there's going to be, since the string is actually exerting a reactionary force on A is also going to exert a reactionary force on the string, okay? And that is how tension is created, since here the pulley is trying to pull this up or stretch it out, something like that. And here, well, this reaction force is what it just happens to be equal to the tension throughout the string. That is why we just directly write down tension here, okay? But yeah, of course, they just asked us for the tension in the string, so that's what we were working with. Again, we just do the usual. We can find out the equations of motions for A and B. Let's do for A first, and then A is moving up, so tension. So always write it down like this, resolving upwards here for A. That is tension minus 2mg. That is equal to 2ma. So tension is equal to 2mg plus 2ma. Sorry for this handwriting. For B, you're gonna be resolving downwards and have 3mg minus T is equal to 3ma, and then T is just gonna come out to be 3mg minus 3ma. This is tension, this is tension. We equate these two and we find tension. No, we have to find out the tension. So yeah, I guess it's fine if you just find out the acceleration first and then put that back into one of the equations and find out tension. Anything is fine. I mean, you could also maybe make A the subject from one of the equations and then put that A on the other. That also works, but I find this easier. WME01 is 3ma, that is equal to 2mg plus 2ma, blah blah blah. M's just cancel out. Oh god. No, I'm having trouble figuring out my handwriting. So you have 3g minus 3a. Let's just write it down nicely. 2g plus 2a. There we go. There we go. 5a is equal to g, so acceleration is g by 5. This is what we're going to be substituting into one of the equations. Let's just go to 2mg plus 2ma. 2mg by 5. So 2 plus 2 over 5. 2 plus 2 over 5 is going to be 12 by 5 mg. I think my voice just got lower. I'm just getting tired. Yeah, that's tension. And now to find the speed of B at the instant it strikes the surface. Okay. So basically the speed at right over here. So basically the speed after traveling 0.5 meters. Now we can use Suvat here. We just found out the acceleration, g by 5. Then you have what? The distance traveled, 0.5. And then you want to find out the final velocity. And you know that the initial velocity is 0 because you're starting from rest. You don't know anything else. So using these values, you can actually find out v. Very easy. U squared plus 2as. So square root of that is 0 squared plus 2 times g over 5 times 0.5. That's just going to be g over 5. I guess you could keep it like just as it is, like root over g by 5. But you could also just... Oh, right. So after putting it to the calculator, I realized this is just 7 over 5. That is a very simple answer. 1.4 meters per second. That's good for me. In the subsequent motion, A does not reach the pulley and B does not rebound. Okay, blah blah blah. Find the time from the instant when the system is released from rest to the instant when A reaches a height of 1.06 meters above the surface. Find the time from the instant when the system is released from rest to the instant when A first reaches... I'm just having to read this a few times because I'm already very disoriented from all that problem solving. It's not even problem solving for me at this moment, honestly, because I have been teaching, and once I've kind of gotten fluent at it and all of this does like get to you at one point. It just gets boring, and well, yeah, I guess that's life. But yeah, what does it say? Find the time from the instant when the system is released from rest. Okay, so essentially from like at this point to the instant when A first reaches a height of 1.06 meters. So you're already at 0.5 meters above the ground. You just want to go to 1.06 meters above the ground. So how long is that? So like 1.06 minus 0.5. So you would have to travel an extra 0.56 meters. Okay, you want to travel an extra 0.56 meters, but you already travel at like 0.5 meters and then an extra 0.06 meters to hit 0.56. That's what's happening. And I do this because I know that once B hit the ground, that's when the string goes slack because B does not rebound at all. Okay, even if B rebounded. I think the string would still go slack. But yeah, once the string goes slack, there's no tension acting on A anymore. So there would be different acceleration of A, and that acceleration is actually just minus 9.8. because the only force that's acting on you is just the weight, and that's going to cause you to decelerate to 0 when you reach the maximum height possible. Now what we need is the time from the instant when the system is released from rest to the instant when A first reaches. Okay, so like the entire time. So why don't we why don't we start this by finding out the time taken for A or for B to travel 0.5 meters. We can easily do that, because we know at this point A has a velocity of 1.4 meters per second. Why, you may ask? Well, as B travels 0.5 meters down, it hits with velocity 1.4, and we know that the particles are connected at that point, at that instant as well. So at that instant, A is also going to have 1.4 meters per second, right? By the time B hit the ground, A also had reached 1.4 meters per second, accelerated at the same rate, both of the particles. We've already talked about that. I just got my British accent there. Okay, so yeah, 1.4 meters per second there, and we can take that as the final velocity here, and the initial was 0 here, and we know we have to travel 0.5 up. We just need the time, so that time is going to be, okay, this is part C, right? So that time is going to be V minus U by A, 1.4 minus 0 divided by, wait a sec, no. Okay, actually we can, yeah, we could just use this. And the acceleration is G by 5. 9.8 over 5, that gives us 5 by 7, okay? 5 by 7 seconds to travel 0.5 meters up. So now I just need to find out the time taken in this little area, okay? For traveling 0.06 meters. So now S is 0.06 meters. My acceleration is going to be minus g, because now I'm moving under gravity. If you're wondering how that's minus g, well, you could just resolve for A. Vertically, taking upwards as positive, what are the forces acting on A? It's just the weight, right? The weight is minus 2 mg. That is equal to mass times acceleration. Ooh, okay, why is it minus here? Well, because a weight is acting downwards and we took upwards as positive, so it's going to be minus. It's in the opposite direction. This is going to be equal to mass times acceleration, so mass 2m times A. So you can see that m, and 2 gets cut off, and you see that acceleration is just minus g. That is how we get minus g meters per second squared. So we know. And why is that the case? Because this string just goes slack. Alright, so S is equal to 0.06 meters. That's how much distance we have to travel after the string goes slack, with acceleration minus g. And we know that right at this point we have initial velocity of 1.4. Let's call that u. Okay, and now with that we have to find out the time. How do we do that? Okay, now we have to use S is equal to ut plus half AD squared. That's just annoying. It just brings in some quadratic equation. I just don't like that. So what I want to do differently is I want to find out the velocity right here, okay? That's what I want to do. Let's do that. Root over, yeah, it's just one extra step, but I just don't like that. That's the thing. And trust me, they won't deduct any marks. This is the right way as well. This is one of the right ways as well. 1.4 squared plus, okay, so minus 2g times 0.06. Let's see what that gives us. 1.4 squared minus 2 times 9.8, 0.06. There we go. Okay, 710 over 25 meters per second. Okay, there we go. Now we can simply find out t using v minus u by a. That just comes from a is equal to v minus u by t, or you could say v is equal to u plus at. All the same thing. So v minus u, so this 710 by 25 minus the initial velocity. So at that point you had 1.4 divided by what is that? Acceleration. Acceleration is just minus g. There we go. That should be our answer. Okay, no, that's not the answer. We have to add it with 5 over 7 next, but you know what I mean. So 7. Okay, let's just, in the calculator we're just gonna put in answer minus 1.4 divided by minus 1.8. Oh god. So we get something like 5 minus root 10 over 35. You could just use this just for a more accurate answer at the end when you add this to 5 over 7, but I guess it really doesn't matter because you could have just taken like 0.0525 and that would have been it, I think. It's all good. So now at the end you just write total time is equal to 5 minus root 10 over 35. That's plus 5 over 7. What is 5 over 7? 5 over 7 is the time taken to move from this point all the way to this point, and then the extra time that we just found out is the time taken to travel this extra 0.06 meters, making this entire distance 0.56 meters, making this entire distance 1.06 meters. So I hope all that makes sense. just gonna do this real quick. This comes out to be 30 minus root 10 over 35. Now we don't want to keep this answer, okay? We want to give this to pretty significant figures, because now actually there's a reason. Because in the calculations, we're using the value G. And in the calculator, we're just putting 9.8, right? But G is not exactly 9.8. G is itself a rounded value, okay? We rounded it to 9.8. So when you use that value and then arrive at an answer, you can't just, write down the exact answer. It just doesn't work. I mean, sure, but it's just a formality, I guess you could say, but that's what you not do. All right, and now you may ask, why did we do that here? Why did we, or why didn't we take decimals here? Well, this is in the middle of the calculation. You don't round off anything in the middle, okay? Just don't do that, just so that you get the most accurate answer at the end, the most accurate final answer, okay? All right, okay, so like after you get this, you just do this approximate sign, and then you just say that this is equal to 0.767 seconds, of course, all the time to 3 significant figures. Okay, that's it. Bye. Peace out. Good night.